When XMM-Newton was launched, we never were expecting it would last 20 years or more.
XMM is an awesome mission. It's one of my top favorite missions of all time.
XMM has been a part of my career from the earliest stages even until now.
My work simply wouldn't have been possible without XMM.
XMM is an X-ray astronomy satellite. It allows us to look at X-ray light coming from some of the most extreme objects in the universe, all the way from stars to black holes and distant galaxies.
XMM has influenced modern astrophysics by having great sensitivity and large collecting area in X-rays, which has addressed science questions which we wouldn't have been able to address otherwise.
If you want to study extragalactic point sources, then XMM-Newton is essentially the only instrument out there if you want really good signal-to-noise in the data.
Most recently, I've been using XMM data to look at the variability of X-ray light from material that falls into supermassive black holes. We've developed a technique called reverberation mapping that looks at echoes of light to figure out the size scale of material as it falls into a black hole.
In 2006, I started working with XMM data, and a couple of years later, I started my Ph.D. work on active galactic nuclei, where XMM-Newton data formed the basis of a lot of that work, especially for my first paper on that.
I started working with XMM data in the summer of 2000. That was when I started doing my Ph.D. research.
I thought it was very cool to have been reading in high school about it being launched and then be able to really use the data from that same telescope in my graduate career to get my PhD from.
My PhD, the majority of it was around searching for a certain type of radiation from galaxy clusters, and so we needed to characterize that really well. And the only telescope that could do it efficiently was the XMM-Newton Observatory.
Actually, all of my thesis, except for the theoretical work, required XMM data. All of the active galaxies that I studied were data taken from the XMM archive.
XMM has been around for 20 years and has just this phenomenal archive of data. And so a lot of this archival data can be searched and new science results can come out.
Without XMM, astrophysics would not be as far as it is today. There's certain science that XMM can do that other X-ray observatories can't.
Time-domain astronomy is going through a revolution. There's gravitational waves detected, there's several kinds of weird supernova detected, and having an X-ray instrument to simultaneously operate while these optical instruments are operating would be extremely beneficial.
Many objects change. They have flares and outbursts, so it's really a key observation to have everything from the X-ray, the optical, and the UV all precisely at the same time.
XMM can contribute to the future by serving as a pathfinder to find really interesting sources that can then be followed up with the next generation of telescopes.
The continued opportunities for time domain studies, which are both photon hungry and just overall time hungry, is an argument for keeping XMM going for as long as it's technically feasible.
We really need to support the observatories that we have and keeping those aloft, because those are the things that excite everyone about science, and especially that excite students to go into it.
I would say that my career has really been inspired by XMM-Newton and has followed along it in a lot of different ways that I didn't expect.
It's remarkable to me that XMM is still performing at the level it is 20 years after the mission originated, and really that's the best possible PR for the mission.